In this next video, we're going to talk about generic functions. But before we get into that, I want you to spend a moment to read through these two functions that are implementations of the includes algorithm we looked at a few videos ago, and see if you can spot the differences between these two functions. There's a related question on Gradescope about this, and I want you to pause the video here, spot the differences between these two functions. All right, great work. As you noticed, these functions are very similar, and it feels like we've got a lot of duplicate code that is shared between these two functions that's not meaningfully different, right? The same algorithm is being applied to both lists of type node string and type node number. So is there a way that we can avoid this redundancy in our code? And the good news is, yes, there is. We don't need to have duplicate logic for functions like includes for every type of node, right, that we might want to use. So we're going to see that just like we can generically type classes so that we can have classes which can have properties whose types aren't decided until we need to go and use it, like we saw with the node class, we can have functions who have generic types as well, so that we don't have to know exactly what types of parameters some function is dealing with until you actually go and make use of that function. And a general rule of thumb here is if two functions really only differ in their types, such as their parameter types or the variable types inside of the function or the return type, you can replace those duplicate functions with a single generic function. And so the things that were similar in the previous example were, where the code differed were the names of the functions, of course. You can't have two functions of the same name in our programming language. And then the types of their parameters. And what we're really focused on here are the types of those parameters, right? And that's what we're hoping to make generic as a part of having a generic function. So then we could hopefully have just one includes function that would work for any type of list that we wanted to be able to test whether some value is in that list. So how do we make a generic function? Well, the first thing we're going to need to do is designate that a function is going to be generic for any type T, right? So just like we saw the diamond syntax when we were working with a generic class, here we are going to see that we are using the diamond syntax again to specify that a function is going to be generic. So notice that we are putting the diamond T in front of our parameter list. And what we're saying here is includes, as the very first step of this of transforming includes to be a generic function, includes is going to be generic for any type T. Now we're still going to have more work to do, but this is an important first step to take to say that, hey, programming language, this is going to be a generic function for any type T, right? So where do we go from here? We're going to next try and identify where are the places where only the type changed in our otherwise identical functions, right? And so in this case, the places where types changed, notice were node of type string and number changed. So that's one place where we saw some redundancy or we saw a difference. Otherwise, these were exactly redundant in their name and type. And similarly, the types for the second parameter were different, right? And notice that there's a correspondence here. We're searching for a string in a list of type node string. We're searching for a number in a list whose type of node is specifically number, right? So there's a correspondence there. So what we're going to do is replace those types that changed between those two definitions with T's, right? So now if we wanted to try and read this updated definition, what we're saying is includes is generic for any type T, and our first parameter is a list parameter where we're talking about a node of any type T, and that search parameter is also going to have to be of type T, right? Finally, inside the function body, and this won't actually be true in our includes example, but if we used a type inside of our function body that needed to be generic, we would need to change it as well. So for example, the generic cons function that we've been using so far, cons is generic for any type t, and its first parameter data will be of type t, and next will be node type t. It's going to return a value of node type t. And notice that previously what we would have needed to say is some concrete type, but what we want to do is make that a generic type, right? And so if we were defining the cons function generically, we would need to specify, okay, well, when we go to actually make a value n inside this generic function, we need to be sure that its type or its newly constructed object is also going to be substituted with whatever t was concretely, right? So if we called cons and data was of type string, then we would get a new node of type string here. Right? What I want you to try doing next is opening up the O3 generic functions app in today's lecture materials. Your goal is to convert the includes function to be a generic function. And you're going to do this following those steps that we previewed on the earlier slides. You're going to add the diamond T syntax just before your parameter list. You're going to replace the specific string type with the generic type T anywhere you were using string in the definition of the includes function. And in the main function, rather than using the specific calls to include string and includes number, those are two functions that are also defined that have this duplicate logic implementation, you want to use the generic includes function instead. And your last goal to just prove to yourself that you've removed this redundant code from your program is you can delete the include string and includes numbers functions. So let's actually take a quick look at this. Here is my O3 generic function app. And you'll notice we make a list of string values. So foo followed by bar followed by null, 110 followed by 41 followed by null. And then we are calling for each of these, does the list strings include the string bar using the includes string function? So that's defined here. And the includes number is defined down below it. And notice that neither of these are defined to be generic functions. And so your goal is to make this includes function generic and then replace these two calls in main such that it uses that generic function definition. So spend a moment doing that, and then we'll work through this code example together. You can pause the video here. All right, let's try and make this function includes work generically for any type T. So the first step, and I'm going to give myself just a little bit of extra space here. The first step in making a function generic for any type T is to place the diamond syntax in front of the parameter list, right? And now we can use this diamond T or the type T in the definition of the parameters or anywhere in the body of the function as well. And we're trying to say that this will be a generic function that's generic for any node of type T, and the search parameter will also be generically any type T. Right? We don't actually need to change anything about the body. We can focus on the declaration at first. And that's the only place where those types actually came up and had any meaning, right? We didn't need to change any types inside the body because there were no types explicitly declared inside of the body. And so now we can replace our function calls up here. We don't have to use include string. I'm going to delete the word string and delete the word number here. And notice that now we're calling function with an input type of node string, right? So if we looked at its type, we can see that its type is node string. So this is the first node or the head node in our list of the strings foo followed by the node with bar in it followed by empty string, or sorry, empty list. And we're searching for the string bar, right? And so this function, when we actually went to call includes, the concrete type for T was string based on how we used it. Now in the second example, notice we've got a list of numbers. So when we called includes with numbers, whose type was node number, T was concretely going to be number. And so the 550 is also a number which would have plugged into the search parameter. So now notice we defined a single function here that works generically for type T. You give it a list of any type and a search value that matches the type of that list, right? So those two T's have to be the same when we use this, and I'll show an example of that not being true in just a moment. Then we've got this algorithm that will work generically for searching any list. We don't have to, if we had a list of some objects, like a list of weather data or weather rows, right? We wouldn't have to write another includes function to work with that. We could use the one that we defined here. And so now we can get rid of these functions that we had defined below to remove that redundancy in our code. Right? So just to prove to you one other really important thing and observation with generic functions is I'm going to add one more search here. Numbers includes bar, right? And so this doesn't really make sense, right? So can I search numbers for the string bar? Well, our programming language is trying to help us out here. And notice the red squigglies are telling us bar, which is a string, is not assignable to a parameter of type number. But that's funny. Didn't we say that T was generic for any type, right? Well, we need to be careful with that because when we make a function call like we're seeing here, where includes numbers, and numbers type is specifically node number, right? What TypeScript is doing is it's saying, okay, well then T must be number, right? And as soon as it knows one of these values, it starts to try and figure out the other places and says, okay, well, if that T was number, then this T also has to be number in this given function call. But when we go to check and see, okay, well, did you actually give me a number here? No, you gave me a string, so this doesn't work out, right? And so when you call a function, when you get to the point of making a function call, when we substitute for T in any given call, those T's have to match up, right? They have to be the same type that we're concretely substituting in. So here, numbers was node of type number, so T would have, in the search parameter, also needed to be number, right? The same would be true in reverse. If I had tried to say, does strings include 550, right? So I'm going to say, does strings include 550? And notice we get that same error, but it's the error in reverse. An argument type of 500, which is a number, is not assignable to a parameter of type string. And so notice that T in this call was going to need to be string to work out in both the node T position and the search T position, but it wasn't, right? In the second parameter, we tried to give it a number. And so it wouldn't have made sense to be able to plug in two different types here, right? Because the first value of a list is always going to be the type of that node, right? So the first value of a string list is going to be type string. And what would it even mean to say, is a string exactly equal to a number that we're searching for, right? And so these generic types are trying to not only provide the flexibility of allowing us to search or write a function that works for different types of lists and different types of parameters in ways that we don't have to redefine functions, but it's also enforcing some rules, as we just now saw, that ensure that we're not trying to do anything that wouldn't make sense, right? We're not saying you can actually use any type in either of these positions you want. What we're saying is when you call this function, you can substitute any type for T, but wherever you make that substitution, it has to be the same for that given call to this function, right? So when we called includes with a list of numbers, T was number, so the search parameter also needed to be number. We'll get some more practice with this concept because this is going to wind up being important to where we're going. And it's admittedly one that can be a little bit difficult to grok at first. But in this problem set that's currently out, the linked list utilities, you'll be writing a bunch of generic functions that work very much like includes, but implement different algorithms instead, generically for many different kinds of linked lists. Great work getting through today's videos.